Good evening, everyone. Welcome to the fourth in our webinar series. Tonight we're here to talk about EMF and EMI. Before we get into the formal proceedings, I would like to pay respects I'd like to acknowledge the various traditional owners of the lands on which we meet and pay respects to their elders past and present, and wish to recognise any Aboriginal or Torres Strait Islanders people present here today. My name is Michael Willis. I am the Integration Manager for the Western Vic project. I am part of the project management team. I'll be facilitating tonight. We have with us tonight some of the study leads looking at EMF and EMI, who will talk you through the scope of the studies they're doing and the existing conditions. The topics for talking through today, we're going to look at the scoping requirements relevant to the study, the scoping requirements which are set by the government, by DELP impact assessment. We're going to talk about how the community input was used into these studies. There'll be some general description about, what are EMF and EMI, and to make sure we all understand them, and to talk through the findings of the existing conditions report that's been completed. We're also going to hear about the considerations that will be included in the impact assessment at the next phase and the next steps. The format for tonight is about half the time to hear a presentation from our specialist, and the other half will allow for question and answer time. Just by way of housekeeping, because it is a webinar and there are many people on here, it requires that we have the people on mute because we would all be talking over each other. We may not be able to get to everyone's questions today, but we'll certainly try. Please put your questions in the chat at the bottom of the screen, and I will ask them of our specialists as we go through. Any that we can't answer tonight we'll use to update our frequently asked questions on the website. And just a reminder that offensive language and personal attacks will not be tolerated. We are going to finish the session tonight at 8:30. Just by way of overview, the diagram here gives you a representation of the process of the project. We're in the middle of the planning approvals phase. We're working through the EES and the studies associated with it currently. The studies have two halves to them. One is to look at the existing conditions, which is what you're going to hear about today. And these, all the studies are overseen by an independent group called the Technical Reference Group, who reviews all of these studies as they come through. Just to make the point that today we can't talk about impacts in detail because that stage of the process has not been completed. You will, at a later stage when the EES is put out for public submission, get a chance to see all of the assessment in detail. But today we need to limit questions to focus on the existing conditions. Today we are lucky enough to have Rodney Urban join us. Rodney is a specialist with over 20 years experience in EMF and EMI. He has a PhD in engineering, specifically looking at magnetics, and has a broad range of international experience working on transmission lines. Rodney is joined by some of his team to assist in the presentation and answer questions. If you wouldn't mind putting your cameras on now, guys, that would be great. Rodney's joined by Andrew and Colleen today. They are part of the specialist team from Jacobs that are completing the study. Over to you, Rodney.
Great. Thank you, Michael. So I'll just share my presentation. Great, thanks. As Michael said, so the topic is electric and magnetic fields and electromagnetic interference, looking specifically at the existing conditions along the Western Vic project. Okay, so under the environmental effects statement, there are 3 specific requirements in the scope. So we're looking at risk to human health, and specifically from electromagnetic emissions from the project during construction and also the operation of the project. Then also the impact or potential impacts on interference to communications and infrastructure systems. And then the third requirement is to investigate sensitive receptors. So these are particularly sensitive receivers that could be affected by electromagnetic emissions from the project. As part of the process, we have elicited feedback from the community. And so the key concerns and points that have been fed back to us have been around potential health effects from EMF exposure, and also concerns around the potential impacts on livestock, apiaries, and native wildlife. And then finally, the potential interference to medical devices, telecommunications, radio and TV reception. So just upfront, some basics about EMF and EMI. So electromagnetic fields, or EMF, in this context refers specifically to biological effects that may be caused by extremely low frequency fields. Whereas electromagnetic interference, or EMI, is referring to the interruption or loss of functionality of electrical and electronic equipment due to the emissions. A key characteristic of EMI and EMF is the frequency of the interference or the fields. And that varies over a very wide range. So I've already mentioned that for biological effects, we're looking at very extremely low frequency fields. And you can see on this representation, this graphic representation, that starting on the left-hand side, we've got these fields, electric and magnetic fields, that are varying sinusoidally between a maximum and a minimum. And at the extremely low frequency, these will vary very slowly with time. So for the power system that we operate in Victoria, the frequency is 50 hertz, so 50 cycles per second. For different devices and appliances, their frequency does increase. So if we look at your radio and TV reception, their frequency goes up into the megahertz. So that's 1 million cycles per second and more. And then cell phones up to gigahertz, which is a billion cycles per second. Those emissions, those field emissions, are non-ionizing. So what that means is that the energy within those fields is not enough to displace or break out energy, electrons from atoms and molecules. When you get beyond visible light, which is in the very high frequency range, then you start to get ionizing fields. So these are fields in the X-ray, ultraviolet, radioactive, where the fields are able to displace charge and electrons from atoms. That's not the case for EMF and EMI that we're discussing in this presentation. So some further technical background to electric and magnetic fields. These fields are found everywhere where we use electricity. The electric fields are formed due to voltages that are applied to electrical and electronic equipment, and the fields are measured in units of volts per meter. Magnetic fields are caused by the flow of electric current from the source, in this case a plug, to the luminaire, to the light. They're measured in units of Tesla. The electromagnetic fields are strongest closest to the source, so that's the voltage or the current in the conductors, and that decreases very quickly with distance away from the source. The Again, electric and magnetic fields that we're talking about are operating at extremely low frequencies. So we're talking about 50 hertz or 50 cycles per second. We've got a very simple graphic representation of the two fields on the slide. And so we've got a general purpose outlet or wall plug, and that's supplying electrical current to the light sitting on the table. On the left-hand side, we've got the electric fields, and on the right, the magnetic fields. These look very similar, and that's because they work hand in hand. They're both present due to the voltage and the current in the electrical supply. The key difference, and it might not be obvious from this drawing, but you can see on the right-hand side that the white arcs that represent the fields, the circles and the spheres, on the left-hand side, those are not penetrating through the table. However, on the right-hand side, which are the magnetic fields, they do penetrate through the table. And that's a key difference between the electric and magnetic fields. The electric fields are shielded, but most materials, the materials, construction materials that we use in houses and in most items are able to shield the electric fields. However, the magnetic fields are not easily shielded by your normal materials. In terms of typical strengths, so there's been a lot of work done, a lot of measurements and research over a number of years. And on this slide, we've collated from various sources available on the internet, and we've provided those sources in this slide. Measurements that have been done across a wide range of electrical and electronic appliances, household items, and also items that you'd find in your general neighborhoods. And we've broken it down into typical magnetic field strength ranges and also electric field strength ranges to give you an idea of what those type of ranges will be. So we can see there in the home and office items like electric stoves, refrigerators, kettles, televisions. We're talking about field strengths in the order of 0.05 up to about 3 microtesla. So microtesla is 1/1,000,000th of a Tesla, which is the standard unit of measurement for a magnetic field. You can see as the electrical devices, appliances use more current. So a hairdryer requires more current to heat the air. And so with that increased current, we have increased magnetic field strength. So we're getting up to about 7 microtesla for a hairdryer. In your public streets and neighborhoods, where we've got bulk supply of electrical power to entire neighborhoods, we do have similar comparable field levels. And the reason why they're comparable, even though there are larger currents flowing, is because we have increased distance between ourselves and the infrastructure below the street level. So if we look, and as I mentioned, it falls away really quickly. So when we get to street side power lines, so overhead power lines that we're 10 meters away from, those levels are actually lower than the measured levels associated with hairdryers in the household. And then you get to high voltage transmission lines, which is really what we're studying as part of this project. And so those power lines, the conductors are much higher up in the air. And so the distance between yourself and the current that's flowing in those conductors and the voltage applied to them, it drops away really quickly. And so again, we have magnetic field levels that range between about 1 and 20 microtesla. So these are measurements that are done by ARPANSA, the Australian Radiation Protection and Nuclear Safety Agency. And these measurements are actually done in Victoria. We've also got electric field strength measurements. So there aren't too many of those published. A lot of the focus has been on magnetic fields and potential impacts of magnetic fields. And like I said in the previous slide, those are not easily shielded by your normal materials that you find, your everyday materials. And so there's been a lot more focus on magnetic fields, but there are some published documents of measured electric field strengths. The units that I mentioned previously were volts per meter. Yeah, we've got kV per meter. So that's generally how we define fields around electrical appliances. And that's 1,000 volts per meter in a kV per meter. But these are very low levels, 0.003, so 3 volts per meter, up to about almost 1 kV per meter. Then under high voltage transmission lines, so that's one of the key factors or key defining properties of a high voltage transmission line, is that it is energized at a very high voltage, and so those electric fields are a bit higher, up to about 9 kV per meter measured values. Now, with the potential impacts, or the concern around potential impacts on human health, there's been a lot of research done into biological effects of electric and magnetic fields. That's been ongoing since the 1970s, so for over 40 years, nearing 50 years. And the two main areas of research that have been reported are epidemiology or population studies and laboratory studies on animals. And the latter is studies that have been done on biological effects, whereas the former are studies that are done relating general population characteristics and behaviors to issues or problems or effects that have been identified or in the general population, and trying to find correlations between the two. Now, the laboratory studies or the biological studies, those have been very wide. So over the course of 40 to 50 years, the research has been into all possible areas of medicine, the bones, carcinogenicity, cardiac, calcium homeostasis, leukocytes, pineal glands, muscles, nerves, reproduction, neuroendocrine systems. So it's been a very thorough body of science over those years that has looked into potential effects on the population. Now, the biological studies have found no adverse human health impacts and have not found a mechanism in which extremely low frequency electric and magnetic fields can cause any of those or any issues in any of those human systems. The other concerns that were expressed were within the community and with the feedback were around livestock and the potential impacts of EMFs. This has also been studied over the past 40 to 50 years across the world. And we've highlighted a number of quite significant studies that have been done, and we've listed a few over here. So in the USA, in Ohio, in the 1970s, there was quite a thorough study that was done across 18 farms that were directly under a 765 kV line. So that's an extremely high voltage line. And with all that research that was done specifically on behavior and production of dairy cattle, no impacts were reported or identified as part of the study. There was also a 2-year clinical study on 11 livestock farms, again under a 765. So these are the highest voltage lines that are generally used across the world, and so have quite significant electromagnetic fields associated with them. This was a study in Canada, and again, no health effects. This specific study in Canada was also a little bit wider. It didn't just consider dairy cattle, but also sheep and pigs, horses, beef cattle. And again, similar conclusions of no impacts. And like I said, there are numerous other studies and ongoing studies and quite recent studies that are reported and that we've pulled out of the literature and based the effects on. So in terms of what exposure guidelines have been set up, so there has been a lot of concern, and there's been a lot of research done over the past 40 to 50 years. And out of that research, prudently, the World Health Organization has endorsed or recognizes 2 international guidelines, which are strongly based and rooted in that research that has been done. The first is the ICNIRP, or International Commission on Non-Ionizing Radiation Protection. And so it's published in 2010 a guideline document on limiting exposure to electric and magnetic fields. And there's also the IEEE, which is the North American standard, C95.1, again on potential effects and impacts on of EMFs on people. Now, the Australian Radiation Protection Nuclear Safety Agency, or PANSA, is the Commonwealth Government's agency responsible for protecting Australian people and the environment from harmful effects of radiation, including non-ionizing, extremely low frequency electric and magnetic fields. And after doing considerable research, so PANSA was formed in 1998, and since its formation, it's been doing research, and it's been reviewing the research that has been done. So there's a large body of scientific research which it's reviewed, and it has in 2015 at its general meeting endorsed the ICNIRP guideline as the appropriate limits or reference levels to be applied in Australia. So it recognises the ICNIRP as international best practice for protecting people against the effects, possible effects of electric and magnetic fields. So these ICNIRP guidelines, they define general public exposure reference levels for individuals of all ages and varying health status to electric and magnetic fields. They are compared to measured field levels at 1 meter above the normal standing surface under a line or adjacent to a line. And those reference levels are 5 kV per meter for an electric field and 200 microtesla. So going back to the previous slides where we saw typical measured levels, we were talking about less than 1 microtesla being a typical level measured in a household environment, and possibly going up to a few microtesla near high voltage transmission lines and electrical cables under sidewalks and in street areas. So they're much lower than these reference levels that have been defined by the international community. Moving on to electromagnetic interference. So the high fields that surround the surfaces of the transmission line conductors, those, because they're extremely high near the surface of the conductors, but much, much lower near ground level, which is where people are exposed to EMFs, they're able to ionize the air immediately surrounding the conductors, and that generates partial discharges, which is a very fast transient effect that generates electromagnetic fields. But these fields are much higher in frequency than what we've been discussing previously. So with EMF, we were talking about 50 hertz or 50 cycles per second. Now with the EMI, we're talking about much higher frequencies. So the frequencies of interest are typically around 500 kilohertz or 500,000 cycles per second, all the way up into the megahertz range. And so on that picture at the bottom of the slide, we're talking about interference to radios and TVs. So it's in that mid-range. And the frequencies are generally lower than cell phone transmission. So it's really most likely interference with radio and television communication, not so much with cell phones or higher frequency devices. Now, devices that are typically sensitive to this include medical and research equipment, imaging equipment that requires very low background field levels, because the imaging equipment is using electromagnetic fields to image the body, and also microscopic details. There are also active implantable medical devices which can be affected by magnetic field exposure specifically. So we're talking about cardiac pacemakers and the like, cochlear implants. A lot of research has also gone into the potential impacts, and there is a responsibility for the manufacturers to make their implantable devices immune to typical magnetic fields. So we're talking about magnetic fields at the levels of the ICNIRP reference levels, which is previously what I showed you, and that was around 200 microtesla. So typically levels that comply with that value will not interfere with implantable medical devices. Also, and quite importantly, pacemakers are designed to fail safe. So if they are interfered with, they do revert into a fixed pacing mode, so that it will be uncomfortable, but it's not a significant medical event. Another form of interference is where the transmission line conductors and towers actually physically block transmission paths between communication towers. And so when designers set up communication links, they do look at what is there currently. And when you add very tall structures or tall structures to the landscape, it can interfere with it. It can block those normal communications. Those effects are generally not that significant though, because these are conductive structures. They don't have a huge impact on the quality of reception of radio communications. But this is something that we do look at as part of the design process. So what have we done so far? So at this stage, we're at the existing conditions stage. And what we've looked at is to identify where there are existing transmission lines. And we've measured the field levels, the electric and magnetic field levels, and also the electromagnetic interference levels under these existing lines. So these are 220 kV, 500 kV transmission lines, which are the same and similar voltages that are being designed as part of the new project. We've also identified sensitive receivers within the area of interest for the project. And finally, we've identified radio and mobile communication links within the area of interest to work out just how, what level and what interference is currently within the area of interest. So we have a description here, a map of the area of interest in green. And we've got the existing power transmission lines, which are in pink. And we've got sub-transmission lines in orange. So sub-transmission lines are at lower voltages than the transmission lines. So as I mentioned, transmission lines are 220,000 volts and 500,000 volts. The sub-transmission lines are typically between 33,000 and 132,000 volts. So slightly lower voltages. We've also looked at point-to-point radio communication links within the area of interest. And on this map, you can see again the area of interest, this time shaded in pink. And what we've drawn out are all the radio communication links in yellow that intercept that area of interest. So these are all items that during the impact assessment, we're going to look at to see whether the project and the works associated with the project could possibly interfere with those devices. In terms of very sensitive receivers, we have also looked at where there are medical facilities. And as I mentioned, some of the medical imaging equipment is particularly sensitive to magnetic fields. But as you can see over here, as part of our existing conditions assessment, the closest medical facilities are quite some distance away from transmission lines. And the electromagnetic fields do drop away really quickly with distance. In one of the previous slides, you saw as little as 10 meters away, that field dropped down significantly from the field directly above the cable, the street side cable. In terms of electromagnetic interference, we have looked at existing AM radio receivers. So AM radio operates at lower frequencies, and so that is more susceptible to interference from transmission lines. But we've also looked at FM radio and terrestrial TV reception as well. In the eastern part of the area of interest, there are, again, medical facilities that we've identified. But again, the distances between the existing infrastructure and these medical facilities is quite significant, which is what you'd expect. It's part of the process of setting up sensitive medical imaging equipment, is to assess the existing conditions and where potential interference sources are, as part of the due diligence of locating that facility at a particular site. So during the impact assessment, we'll make sure that with the new electrical infrastructure going in place, that again, we do that same due diligence and check to see that we won't interfere with the existing infrastructure in the environment. And then also under EMI, again, looking at AM radio reception and FM and terrestrial TV reception. Terminal stations. So I've spoken a lot about transmission lines. They're a significant part of the project, but they're also terminal stations. And so that's where we've got terminal equipment, electrical power equipment that transforms from one voltage to the other and distributes the voltage and collects it from various generation sites. But these tend to be quite well spaced already from public areas. And we have measured electric and magnetic fields at these sites, but we've identified no sensitive receivers in those areas, but it's something that we have looked at. Going on to the impact assessment, which is currently underway, what we're going to be looking at is the cumulative effect. So it's the existing conditions which we've presented today, but also the impact and the cumulative effect of the additional electric and magnetic fields and electromagnetic interference from the new infrastructure, together with the existing emissions from the existing infrastructure. And looking at electric and magnetic field interference, and also interference with radio reception and point-to-point radio communication links. So our next steps for the impact assessment will be to do EMF and EMI field testing. We've already done quite a bit of that. And then also looking at a detailed impact assessment for EMF and EMI associated with the project. And then finally considering mitigation for any potential impacts on people and the local environment and sensitive receivers. Great, thank you.
Thanks very much for that, Rodney. We will now I'll move into some questions. Thank you very much for that talk, particularly like the examples that you gave. Thanks very much for that. I'll just get these up here. Moira has asked the question, how close can the lines and towers be built to a house or business such as a school?
Yeah, so there are requirements. There are many considerations for siting transmission lines. There's electrical clearances and other safety impacts. And so as part of that process, there is an easement that is defined, and that's well defined in AusNet's design philosophy. And so part of their considerations, EMFs and EMIs, and that's part of the design process. So that will be defined. But from our measurements, what we do know is that the electric and magnetic field levels at the edge of those easements are well below those ICNIRP reference levels, which has been endorsed by APANSA.
Okay, thanks. There's a question here about one of your earlier slides. Your first slide, were they referring to 500 kV transmission lines?
Yep.
That's from Anne.
Yes, that's right. So that's the highest voltage associated with the project is 500 kV.
Right. You might have answered this one just to be safe. Sam wanted to know, my dad has a pacemaker. Is it safe for him to be near the transmission lines?
Yes, so like I said, a lot of research has been done into that, and there are guidelines, because we do have line workers and people who work around transmission lines that do also have pacemakers, and so that is well established, and there are standards in Europe and the US, which we've referenced, that address that. But yes, the short answer is yes, that is safe.
Great, thank you. We have another question from Anne. She asks, does the halo effect of electromagnetic fields of a 500 kVA transmission line affect the flight of birds? It's two-part, and can it cause them to lose orientation or collide with the wires?
Yes, so again, yeah, good question. That there's been a lot of research into that. It's an interesting phenomenon. It's got many different effects. So that halo effect will generate electromagnetic interference, which is what we've discussed, but it also generates audible noise, which can affect animals, wildlife as well. However, there is no recorded, or the research has not indicated that it does affect behaviors of wildlife or animals, either through the electromagnetic interference or the audible noise that's generated by that effect.
Okay, thank you. We have a question from Nick. Is there a difference in EMF and EMI between DC and AC lines?
Yes, definitely. Good question. So they are quite different in how they interact. The DC lines generate ion fields. So that halo effect that was mentioned previously actually generates electric charge. And so under a DC line, it can actually charge up fences, and it can have a quite a different effect through that ion space charge that the wind blows around, and can have effects up to quite a distance away from the line. The AC lines don't have those same effects because the fields are contained, the space charge, the ions generated are contained within a small area around the conductors, because with AC, the fields are changing polarity the whole time. So that space charge moves away from the conductor, then back in towards the conductor continuously.
Okay, and this project is AC or DC for people who don't know?
It's an AC project.
Okay. Great, thanks very much. We have another good question from Moira here. Will my tractor GPS work under the lines?
Yes, so that's one of the items that we're looking into. There are the high frequency emissions from the lines. Those tend to be highest under heavy rain. So the rain does have an effect on the electromagnetic interference from the transmission lines. But those emissions tend to be at lower frequencies than what the GPS is operating at. And so we maybe have interference to AM radio, which is in the frequency range about 500 kilohertz to 1.5 megahertz. Your GPS is operating at much higher frequencies, depending on the specific device, but they're all well above that frequency range. And so no, it won't interfere with the GPS.
Okay, thank you. That was a good answer. I think you may have answered Elizabeth's question as well, who asked about her radio going crackly under power lines. Mm. Is that?
Yes, so that's right. So that is the effect. That is interference, and it's more prevalent with AM radio. So the modulation technique that's used for the radio amplitude modulation is more susceptible to interference, and that crackling effect is the interference, and it is much worse under heavy rain. But it's one of those effects that we are considering, and the voltages, and it's a voltage effect, so the voltage that's applied to the transmission lines will be the same as what will be applied to the new transmission lines as what is currently, so that's the existing condition. So what we've been doing is we've been measuring those radio frequency emissions from the existing AusNet 500 kV, 220 kV transmission lines in Victoria, so that we have a benchmark. We know what we're expecting with the new infrastructure.
Okay, great, thank you. There's a question here from John. Does the magnetic radiation go beyond the easement, one of these lines?
Yes, it does. So that slide that I showed with the lamp on the table, so very few materials actually shield from extremely low frequency magnetic fields. They continue on virtually to infinity, but their levels drop significantly the further away you go from the conductors. So at the easement, which is quite a distance away from the conductors, they're already extremely low. And by the time you get a significant distance away, they've dropped below the background level, remembering that the Earth's magnetic field, the Earth has a magnetic field, a background DC magnetic field. So often the equipment that we use isn't actually sensitive enough to pick it up, a few hundred meters away from the transmission line because it's dropped to such low levels.
So, okay, thanks. We've got one from Anne here. Is it safe to work with machinery under transmission lines during rain?
Yes, so the transmission line's been designed so that the insulation won't fail under environmental conditions. So the electric and magnetic fields that we've been discussing and the electromagnetic interference, these are very small field levels that cannot cause safety concerns, physical safety concerns. What we are looking into is electrical and electronic equipment not operating correctly, so that can have its own safety issues if it's not operating correctly, or in the most part it'll just be frustrating. But these are items that we're looking into as part of the impact assessment, and equipment is designed to be immune to interference. So it's an extremely unlikely situation that you would see any loss of functionality in equipment under a transmission line, whether it's in rain or at dry conditions.
Okay, thanks. We have a question from Abigail. She says, my father has DBS therapy, neurostimulator for his Parkinson's. Yeah. Can he work under the proposed line safely for a duration of time on his property?
Yes. So again, that's an active implantable medical device, and it has been researched thoroughly. There are standards that have been developed around that, and the manufacturer of the implant device will make that immune to electric and magnetic fields that you would typically find in the environment, including in and around transmission lines.
Sounds good, thank you. We have a question from Darren. My apologies, Darren, it's quite a long one. I'm going to summarize it a little bit here. It says many countries have defined setback requirements for high voltage lines under what's called prudent avoidance policies. Austria, 400 meters, the USA, generally not less than 2.5 times the height of the tower. There's a number of other examples. Is there something equivalent in terms of Australian standards?
Yes, so not in standards, but there have been reviews done both in New South Wales and in Victoria, and there is a practice of prudent avoidance that is applied. So it is defined in an Australian context, and the Energy Networks Australia (ENA) EMF handbook does have a good description of what prudent avoidance means in the Australian context, but that is part of the design process, is prudent avoidance.
Okay, sounds good. Is there a, not to put you on the spot, is there a figure you're aware of that is a parallel, or is it something that you need to understand in context looking at the guidelines?
Yeah, I think it's in context. So prudent avoidance is what you know, what you can do as part of the design process. So it's looking at different options, and different parts of the world apply it differently. It's line selection and it's line design, and these are all processes that are well entrenched in the transmission line design process in Australia.
Okay, thank you. We have a question from Trevor. He says, regarding the testing undertaken near 500 kV and 220 kV transmission lines, can you talk about the types of place it was undertaken, and is the topography similar to what's proposed for this project?
Yes, so the testing, the specific locations of the testing, I'd probably have to refer that to Andrew, who actually went out and did the testing. But in terms of topography, like I said, the magnetic fields are not attenuated, they're not shielded by the topography. So that won't have an impact on the specific levels. The topography does influence the line design, and you know, where you've got quite hilly country, you would have greater clearances to the aerial conductors in some locations. So it's very specific to the sites. But what we do is we measure at mid-span, so that's midway between towers where the conductors are lowest, so that we get a reasonable measure of what we expect to be the maximum magnetic field under that line. I don't know, Andrew, if you can comment on where the testing was done.
Yeah, I guess in terms of the topography, it was sort of done in various locations. Yeah, so we tried to capture, I guess.
Sorry, Andrew, your line's a bit disrupted there. We can't quite make you out. We might just move to the next question at this stage. Chris has asked, will my calving heifers be disturbed by the transmission lines?
No, so there's a lot of research that's been done on behavior and calving behaviors for herds and for different livestock. All that research, and it's peer-reviewed journal research, has concluded that there is no evidence that it does impact animal behavior.
Okay, great, thank you. We've got one here. Oh, it's a good one, actually. But why do my fences become electrified near existing transmission lines? Sometimes I get zapped. Mick has asked that question.
Yeah, so it's not actually the fence that's getting electrified. It's your body in an electric field where you charge up to a certain voltage because you're wearing rubber-soled shoes. If you were standing barefoot, you know, in a wet paddock, you would be unlikely to experience that. It's just that you're insulated from ground and you're in an electric field, and when you touch that charge that's on you, that's been induced on you, discharges into the fence, which is earthed. So it's at earth potential, and so there's a voltage difference between you and the fence, and it discharges. But that's the human body and your skin and the rubbish soles. That's not a lot of charge that it can store, and so that discharge, it's only because it's through a very small portion of your fingers, which have sensitive endings and nerve endings and receptors. That's why you feel it. It's not dangerous. There was that previous question about AC and DC. So under DC transmission lines with the iron flow, that can charge up the fence. The fence can also become charged up, but again, that's if you've got timber posts and your steel wires are not well earthed. If you've got steel waratahs or if you just put a few steel waratahs on the fence to earth it, there wouldn't be that issue.
Okay. Thanks very much. Ryan's asked, will the new line interrupt my TV and my internet reception?
So that's a good question, because that does happen. You get faulty fittings. So it's more a maintenance issue. Under normal operation, it won't. But if you've got a failed or faulty insulator on the transmission line, and you know, we see this around Melbourne, not just on transmission lines. In fact, it's probably more likely, or it's more reported on the lower voltages, the 22 kV lines through suburbs, where there's a fault on the insulator that can cause interference to the reception. But that's a maintenance issue, and so that'll be detected and will be replaced, and things will be back to normal, won't interfere.
Okay, thank you. We have a question from Emma. She says, have there been any studies on how EMF affects animals, cows and bulls that are you know, in a Victorian context, or are all the studies somewhere else?
The studies are elsewhere, so we're not aware of. We've done quite a bit of research, a lot of human studies in Victoria, but we haven't found animal studies specific to Victoria.
Okay, great. Are there any more questions? We've got through all the ones that have come through so far that we can ask. Is there a last call for any more questions? Or we will wrap up. Okay. I'd like to thank everybody very much for attending, and very much to Rodney and his team for taking the time to talk through this important issue with us. We will send out a survey at the end of this for some feedback. We'd like to hear how we can improve. There is some upcoming one-on-one sessions with key specialists from the project, where people can book in to ask more detailed questions if we didn't cover things tonight. And as always, we'd any questions for the project team, please, you can reach us on the email address there, and further details on our website. I would like, AusNet acknowledges that these projects, the uncertainty created by them does create concern for landowners and communities in which the projects are based. And we strongly encourage anyone who's struggling at present to reach out to the support services that we've got listed here. They're entirely independent from us, and can provide some support in these tough times. This information is also on our website. That concludes tonight's webinar. There are a few more coming up next week. Please register and join us to talk about these topics if they're of interest to you. Once again, thanks for joining us tonight, and I will see you at the next one.